flip a coin. Before it even lands, you already know something about it, heads or tails, and even chance either way. Now roll a pair of dice, and the question gets richer: which totals are likely, which are rare. Chance has a hidden structure, and it goes further than you'd think. Start with the simplest question you can ask about any of it: how likely? Probability is really just a count. Take everything that could happen, then count the outcomes you're hoping for. Favorable divided by possible. A coin has two faces, one of them heads, so the chance of heads is 1 out of 2, a half. A die has 6 faces, so any single number is 1 in 6. Roll 2 dice, and there are 36 equally likely pairs. Only one of them totals 2, but 6 of them total 7, which is exactly why 7 comes up more often than any other number. But most real questions aren't about one event. They're about how events combine. When you want this and that, 2 heads in a row, you multiply. A half times a half is a quarter. Each flip is independent. The coin has no memory of the toss before. When you want this or that, rolling a 2 or a 5, you add. 1 in 6 plus 1 in 6 is 2 in 6, but add only when the outcomes can't both happen at once. That distinction is everything. Independent means one result doesn't change the other. Mutually exclusive means they can't both occur. Confuse them, and you'll believe a coin is due for tails after a run of heads, but it never is. The coin doesn't remember. Push a little further, and single events give way to the shape of many. Flip a coin 100 times and count the heads. Do it again and again, and the tallies pile up into a curve. Low at the edges, tall in the middle, peaked near 50. That mound is the bell curve, and almost anything built from many small chances settles into it. Every bet also has an expectation, its long-run average value. Wager on red at a roulette wheel, and your expected return sits just below what you put down. On one spin, anything can happen. But over thousands of spins, the average locks onto that expectation, the law of large numbers. That tiny edge, repeated, is why the house always wins. From a single coin flip to the law of large numbers, it's one idea seen at every scale: chance isn't chaos. Count carefully, combine honestly, and the odds reveal a shape as reliable as any law in mathematics.